So we went through this process of learning how to complete the square. We came up with the idea that if I have x squared plus 12x, I can complete this square by adding half of b squared. So half of b squared. The reason why I want to do this is because now I've created this perfect square trinomial. And from this perfect square trinomial, actually even up here, I can factor this into two of the exact same factors. Once I do that, let me focus this up. Once I do that, I can use this idea to think about what we've done in school already. We've created a way to solve a quadratic equation that looks like this. As long as I have a square on one side of the equation, like this, with the variable, I can take the square root of both sides, don't forget my plus or minus, and thus I can solve this quadratic equation. Once I have this fantastic method of solving, I can go through and I can actually solve this to the nearest tenth. I could also leave it in radical form, but let's just practice solving to the nearest tenth. So my trusty t-chart is going to tell me that x plus 6 equals positive root 10 and x plus 6 equals negative root 10. So in my calculator, I put root 10 enter, and that's about 3.16, and I subtract 6 because I'm going to subtract 6 from both sides of the equation, and I get x to the nearest hundredth is approximately negative 2.84. That's the first one. Then I'm going to subtract 6 on this side, and I'm going to do the same thing. I'm going to do the square root of 10, enter, negative, and then I subtract 6, and I get x equals negative 9.16 to the nearest hundredth. So I have a final answer here. And as long as I can get an equation to look like this, I can solve it. So, how can I get an equation to look like that? Well, that's why we learned how to complete the square. And let's remember, in order to complete the square, we take the coefficient of the linear term, cut it in half or multiply it by 1/2, and square it and add it. And that's what you did for homework. We went through this entire sheet and we took half of b and squared it. So what we would add to this, c would be 25. We took half of b, we squared it, so if we were to do that, it would be 17 squared, and that is 289, etc., etc. So let's move on to how would we take this idea and solve a quadratic equation. Well, if I have p squared plus 14p minus 38 equals 0, I can't factor this, I can't solve it by any method right now that I know, but watch what happens. If I manipulate my equation, and that's the coolest thing about algebra, whatever I want to do, I can do, as long as whatever I do, I have to do to both sides of the equation. So I'm going to manipulate the equation to get this 38 and bring it over to the right. The reason why I'm going to get this 38 and bring it over to the right, and I purposely skipped a spot, is because now, again, I can still manipulate the equation. If I take half of b and square it, I add 7 squared to both sides of the equation. And like we said before, I can now take this square trinomial and put it into its factors. You see how the factor connects with what's being squared, or whatever half of b is? And then whatever the plus is here, we have the plus there. So we add 38 plus 49 and I get 87. And now I can do my square root property like I did before. The square root of both sides. Don't forget my plus or minus. So my final, not my final answer, but my answer is going to be p plus 7 equals the positive negative root 87. Now I'm going to be able to set up my trusty t-chart, and I can actually solve this problem. P plus 7 equals the positive root 87, and p plus 7 equals the negative root 87, and then of course I can do my math, unless I wanted to leave it in simplified radical form, but I'd rather you do the math right now. So the square root of 87 is approximately 9.33. I subtract 7 from that, and I get, because I subtract 7 on both sides, so I get p equals about 2 point to the nearest hundredth 33. And then I do the same thing over here, but I have negative the square root of 87, and I subtract 7 from that, and I get p equals negative 16.33 to the nearest hundredth. So I have an answer that I can put in my set notation. And this, my friends, is why we complete the square. So far, we have the square root property. That's if you're given something that looks exactly like that. If not, we can try factoring. But there are no factors of negative 38 that add to 14. So if I can't factor and I can't do the square root property, maybe I can manipulate it so I can do the square root property, which is called completing the square. Soon we're going to have even another method. Now it's time for you to try. Try this one. X squared plus 6x minus 59 equals 0. So I'm going to pause this, I'm going to do all the work, and then I'm going to put it out.